As I mentioned, we are going to talk about HashiCorp Vault. HashiCorp Vault is used to secure, store, and tightly control access to tokens, passwords, certificates, encryption keys for protecting secrets and other sensitive data using a UI, CLI, or HTTP API. So John's going to walk us through the basics of managing Vault secrets without having a binary CLI or UI. I also want to note that this Hangout is recorded and the recording will be made available after post-processing, usually within a day or two. I'll email it out to all of you. The demo will be about 15 to 20 minutes, and then we'll allow up to 30 minutes afterward for questions. So please go ahead and submit your questions throughout the demo through the GoToWebinar portal, and then we will answer them at the end. So with that, let's go ahead and get started. Take it away, John.
Oh, perfect. Thank you, Amanda. Sorry, everybody. I arrived fashionably late, which is terrible. So I would like to cover this topic because a few reasons, right? There were some recent features added to Vault that make this a little bit easier for people to adopt. Somebody starting out with a CLI or a UI obviously needs some automation at some point. And we have recently made this a lot easier for people to use. And I'll show you how that works. Two, I talk about the MacGyver environment when you have a sidecar and you're limited to 100 kilobytes or 200 kilobytes, right? You have to have a tiny, tiny little footprint of something that needs to access Vault. And truth be told, Vault is a nice, powerful product, but has kind of grown over the years. It's now 120 megabytes roughly raw. So if you're going to do a Vault login and retrieve 2 Vault secrets, you shouldn't have to store 120 megabytes in your images for everything you use. So there's a couple of tricks if you're a Linux power user, or not just Linux, I suppose, but Darwin as well. If you're a Mac user, there's some options that maybe are a little less known that you have available underneath the core of your operating system that help you access these secrets without some tooling around it, right? So I give you a couple of options here, right? First of all, CLI, the nice thing about the Vault binary, it ships self-contained. Everything is written in Go in a central way that you can access a service, right? You can run it as a server, you can run it as an agent, you can run it as a CLI, or actually use it to provide the UI, a user interface for easy access, right? Everything is easy to deploy that way. Everything is self-contained. You don't have to worry about dependency issues and different Python modules or Ruby gems that aren't compatible with your Vault installation. But again, the overhead, 122 megabytes, right, for a simple client. And in a world where you have containers that need to be a couple of kilobytes tops, or you have maybe a container that you need to use for troubleshooting that is limited in scope, there's a couple other options you have available, right? I'll show a trick called, if anybody's used the bash/dev/GCP device, this is a great way to access websites when you don't have even libcurl available, right? If you don't have wget, that's one thing. If you don't have libcurl, that's another thing, right? And if you don't have Go bindings or some API binding that you can access Vault over a REST API, here's something that you can do to test it out, right? That applies only to HTTP, unencrypted, right? It's simple enough to do, but obviously not a real-world scenario because you're going to need some TLS involved. You're going to need security. So I go on to a step further in how to access Vault with HTTPS directly, and that requires only the OpenSSL client, right? And there is a couple of tricks along the way. There are a couple of tricks along the way that you can put together a couple of lines of script in an environment. As long as it has an OpenSSL client, you can access Vault. Step 4 as well, if you've got a binding for one of your many languages, that's great. You also have to keep track of the dependencies involved, but it allows native support, error handling, etc. for your language of choice, which is ideal, right? And number 5, other clients, and I'll show even the Fuse client, which presents the REST API as a file system. Jumping into it. So let me just hop off to it. We've got some trade-offs here. We've got simplicity. Obviously, the Vault binary is preferred. That covers server, agent, CLI, and UI. If you have that, you've got simplicity, right? You don't even have just the CLI, but you have a help menu, right? Vault help, explain command. We don't exactly have man pages in the traditional sense that you can say man vault, but vault itself will tell you what are you looking for, and this is how you look for it. Right? This new recent feature, which was added now a couple of months ago, I guess about when we scheduled this, is a dash output curl URL. And instead of actually doing a vault operation, the vault binary will print out a curl option, a curl version of what you're trying to do, which is really good for learning curve, maybe not so much practicality, right? It's just a quick way for you to convert your existing workflow into something that's a REST API. And the cons, obviously, the binary, I said 122, it's 127 right now. I just checked this recently as well. So that's too large, right? So if you're going to have 100 copies of this or 100 clients involved, you don't want 127 megabytes times X storage utilized, right? That's just a waste of space. So this is essentially bootstraps with the bare minimal you can access Vault with. And the audience here, targeted audience, is more the existing Vault user, somebody that has a couple of auth methods, ways to authenticate into Vault set up. Maybe I'm using a JWT, a token, user path, etc., or LDAP. And then B, policies that control which secrets you have access to. Okay, so if I have an init container that's limited to 100 kilobytes, I need to obtain maybe a web token to do some CI pipeline or control the actual environment. I also will retrieve a key value static secret from one of the admins, some guidance on maybe what I'm supposed to do during init, and also a couple of database credentials, maybe a SSH or PKI, right, a TLS certificate. Rather than include a bunch of bindings for 3 little bits of data that I need, I can do shortcuts, right? And I've got a couple of scripts here that I cheat with. So this Vault Raw API is only compatible with Bash. Note that. In fact, Mac OS just changed from Bash to ZSH, Z shell by default, which isn't compatible with this. There is a virtual device that many people don't know about inside Bash, /dev/TCP. And that is accessible for any TCP socket, right? Just if it's plain text, I can say cat this as a virtual file, server/port, and these are the standard environment variables, right? So I can actually do a Vault login. This gets set. The environment variable gets set for Vault server, which will fill in here. My IP address then translates directly into the TCP device at the OS layer, right? So I don't have to worry about any bindings. If I've got a shell access or a Bash access, I can then cat any command, raw HTTP command like this into that, right? And that will fetch me a Vault secret. In fact, if I do this by example, I do have a Vault running locally, and it's both running on HTTP raw on 8200 and also 8201, which is TLS. Okay? If I do this, Vault raw API, and I try to query the sys-health endpoint, which is documented right here. Anybody who needs access to the API reference can find it on vaultproject.io. System/health, right? A real basic static retrieval. I'm not going to have to post anything to it. I don't need to provide any data other than my token, which is embedded here in an HTTP header. Which should fetch for me, Vault address, not server, sorry. I did this for the SEs a couple days ago and I changed it. My mistake. This now fetches and I can see the debug output, a raw HTTP socket. So I actually have to set it to the IP itself. In fact, in this case, it's going to be localhost. You see this is a temporary redirect in the UI. This is the response that any web browser would get, or curl as well. And it should be filling in the actual response. So I can script that. In fact, vault raw is 21 lines of bash. And in fact, vault 300 bytes, right? So I don't have to have an API binding for this when it does work. I don't have to have type safe checking. In fact, it will work in basic use cases. It will fetch me a result, but it won't do dynamic results as is, such as wrapped secrets or things that are advanced features. How do I get the actual curl string? So like the case of sys/health, I use the shortcut that I talked about, right? So vault read dash output curl string, and in this case, sys/help, right? So if I leave this off, vault is going to return to me the actual sys/help endpoint, because really that's all. Now I have to do this. D200. KV/1/test. I'll retrieve actually a default KV1 version static secret. And what is the deal here? What's going on? KV/test shows a JSON document, okay? Static secret. This should be retrieving KV/test. There we go. Okay. So I can retrieve this, or I can add the dash output curl URL. Curl string. I always want to say URL. There's certain versions of Vault that this is not present in. In fact, if you go back about 6 months now, this isn't available. But this was a quickly added feature to enable people to translate their scripts into REST API. Right? So if I had the example here, vault. Maybe I have an init container script or some Packer job that is provisioning my environment. I can say, okay, vault write Kubernetes login config, vault write this, and then vault read a couple of static secrets, maybe a PKI, a database credentials, etc. Right. The easy way to change that from relying on the vault CLI, the vault binary, into a vault REST call is to cheat with this function. Right. If I change the actual vault command into a function that says run vault with the argument right there, output curl string, this then instantly transforms from a vault update command and something that I do in my bash init container with a full vault binary into a script. Right? And this can work as long as I have curl installed. This is the exact same thing without 127 megabytes of bloat. Right? So I don't have to worry about having a binary local. Okay? If I go the step further and I say, well, I don't have curl available, I can quickly adapt this and say, well, I actually need to use the vault raw command. Well, not vault raw command, vault raw API command, which is the vault access by dev TCP. Okay. That's all well and good, but again, in production, I probably won't have raw plain text. I'm going to have TLS involved. And the way to do that, the way to actually use vault over TLS without having curl is to use the OpenSSL command. In fact, a lot of people don't know that OpenSSL behaves as a client. So if I do in the simplest tense, vault via OpenSSL space s_client dash connect to the vault server and port, right? This is the TLS socket running 8201, and then I pipe in a command to it as a standard HTTP GET. This is wrapped by OpenSSL. So again, I don't have to have curl, I don't have to have wget, I don't have to have an API binding. All I need is basic OpenSSL functionality, and I can use this to fetch anything. So if I leave off the here doc, if I just put OpenSSL with the client command, that gives me an interactive prompt onto an HTTP service, almost like I've telnetted into the command prompt. Right? Original HTTP was actually handwritten, so I would type the command to connect to a server, and I would type this manually. Right? It quickly became apparent that why would I do that for every web page? I should automate that by a web browser. Right? Well, this is the original version of that. This is the ultimate low tech, and basically the way you impress people at parties. You say, hey, guess what? I can fetch a URL without a fancy wrapper, right? And obviously I say that sarcastically, but in a pinch, this gets you out of a lot of trouble. Okay? So if I'm in a government hardened environment or public sector or some banking environment that doesn't give me access to what I need, and I still need to access a vault secret, even better, this applies to all of our products, right? This is a standard HTTP interface. If I need to get a console KV or service lookup, if I need to get a Nomad job spec or status, or if I need to get even a Terraform Enterprise Run API, I can use this. Okay? And a step further, and this is what I did, and I published about 6 months ago, I think, is to map all the Vault API endpoints as a fuse file system. Okay, so this is about 500 lines, 458 lines of C++. And apologies for the people who don't like C++, but it was a quick way to get it wrapped up. This is now mounted, my Vault instance at, Mount Vault. Okay. Oh, sorry, my shell doesn't actually autocomplete here, but I can do this. So this, an ls at this directory is essentially the same thing as calling Vault list secrets, right? All of my mounts are available here as directories. And the beauty of that is then I can, AWS cat / vault. There's a KV example, right? So this is now actually behaving as a file, but is an actual vault lookup to the REST API. So if I do a JQ dot, sorry, skip that, my debugger's on. I can treat this as it's a local file. This is using a session token, right? So whatever token I hand it, hopefully I've done a login via one of my authenticated options. I can say, okay, if I'm doing this from a Cube, a Kubernetes service role, I can then list all of my secrets available, authenticate in an init container, and I can present my secrets locally as a file system, right? If I then do, actually go back to fish shell. AWS, so here in this case is the version of a vault command to give me a 24-hour AWS credential, right? If I open a new tab, make that bigger. Same thing is here as a file. It's 24 hours, and this will be deleted after this recording, so hopefully none of these are valid, right? All of these logs, everything will be revoked after the lease expires. So same thing, right? Here I just catted a file, and in the process of reading a file or reading the REST API, I actually created credential set for myself. I can do this with database credentials, I can do this with IAM roles, etc. In fact, I can go into Vault then via the UI, the exact same interface, and I'm going to go through my leases and revoke them so that none of you can. Somebody already has 1,000 Bitcoin miners on my account. I just know it. A sharp group, right? And because I'm in Australia, sorry, yes, I'm in Sydney, there's a whole lot of latency. This takes forever. Okay, sorry. Revoke, right? The beauty of this is I can do this with any of our dynamic secrets. I can do database credentials, SSH certificates by assigned CA. or root CA. I can do PKI, right? TLS certificate on demand at scale with something as dynamic as an autoscale group or a Kubernetes autoscaler, OpenShift autoscaler, right? Vault is intended to go a step further and say, how do we manage credentials in a dynamic world, in some cloud that could potentially have 1,000 customers in 5 minutes, right? So I now have this simple ease of use of this, either accessing by a file system, by again, a bash script here, which took a couple of kilobytes, not even a couple of kilobytes, 300 bytes. And I can do this anywhere. I can do this if I get a cloud shell, right? I have access to bash or a shell environment. If I have even a short-term container, if I can start up a bash container, I can fetch this on another service, right? And if I have console connect, that's a good use case for plain text right here, right? The Vault raw API. You would think in production, I always have TLS. I always have a HTTPS encrypted connection. But in the case of console connect, right, with mesh networking, I may have a local host port here, just like this. And instead of actually being my instance, it's going to be tunneled directly to one of my cloud instances, which is super helpful. And in that case, this simple little script that seemed like it wasn't production ready becomes production ready on a dynamic environment in a multi-cloud deployment. Okay, does that make sense? I'm waiting for the questions to pile up, and I think there probably should be some. I've effectively demonstrated on the fly. And Amanda, actually, can you tell me? I don't see any question thread. Does anybody question?
Yeah, one sec, John. Hold on. So our first question, so we do have a few questions. And if anyone, a reminder, if anyone does have any questions, go ahead and submit them through the portal and we will get to them. So John, first question, someone's asking, isn't OpenSSL more heavy as compared to curl?
Well, it could be, but it's more, I would say it's more common. So if you have curl and it has its own OpenSSL implementation, in fact, if it's dynamically linked, it might actually depend on libSSH, right? So it's all kind of the same animal. That depends on your environment, I suppose. If you can tell me your environment has a OpenSSL client that's double the size of curl, yeah, that's I don't know. That's a different animal altogether. And in the case of some of the API bindings actually requiring libcurl underneath, same deal, right? Nicely enough, the Go binaries don't have libcurl dependency, right? Go wrappers are actually written from scratch as far as I can tell. The interesting thing about that is that some of the environment variables, if you have a custom CA cert or custom CA directory, they take a different environment variable. They don't always use the same kind of environment standards as libcurl. Right? So if you have libcurl and it's a smaller footprint and it has no dependencies, great, right? If you do have libcurl and it has all kinds of dependencies that don't fit in your footprint, then this works for you as a backup plan.
Okay, great. Thanks for explaining. And then next question, are there any plans to support file-based secrets?
Yeah. So I wish I could say that this is supported. In fact, anybody that wants to try this can go use, I think. No, there's actually, that's a couple of different layers to that, right? File secrets. Now, there's two ways. Some people think that file secrets are Vault will encrypt a block volume or file storage or object storage, right? That doesn't happen natively. Vault manages small secrets and keys. Right? If you're talking about support like this, where a secret is actually treated as a file, this is just another client, essentially agent, I should say, right? Like this. If I cat this as a file, this is essentially a separate entity altogether. In fact, if I do this, if I build this Vault FS, 500 lines of C++, it does depend on libcurl and it does depend on libfuse. But that essentially gives me a Vault agent which presents itself as a file system in really a couple of kilobytes. In fact, I think 1.7 megabytes. This is statically linked, right? So no dependencies. 1.7 megabytes total footprint if I don't have any dependencies. And if you have that much available, great. It's a lot less than 127 megabytes for the Vault binary, right? The other thing is that it may or may not match the feature set of your bindings. In fact, I did a Medium post. Come on. We have a great SE Medium blog, by the way, if anybody's not seen it. We have a great team of people around the globe that posted this. And I showed that actually there were a few file systems available for all the products, right? So Nomad jobs are treated as files. And if I write to a file, I create a Nomad job. Console KV, if I write a file to console file system, I suddenly have a console KV stored as well. And in the case of Terraform Enterprise, especially, like I list all my organizations and workspaces, and this is crazy, but I can't find, where's the next page here? It's not showing. I can actually show the link later. Terraform Enterprise, no. I'll have to look it up. But there is a link that explains all of these. In fact, you can show videos here. How these are all independent binaries, including Kubernetes. And what they do is actually list the environments as you would expect them. You know, Linux and I suppose POSIX compliance has this nice idea of everything as a file, right? Even like devices as a file, random number generator as a file. So this is a way to present HashiCorp resources as files, except that this is an independent agent, right, and client. So the interesting thing is that this takes parity, feature parity. If this has an implementation that's deprecated or behind a certain release, it may not support that, right? So it is a little bit independent. I wish I could say that it was bundled into the binaries that we ship. It isn't yet. In fact, there's some Bazel work that the engineers have done on this to kind of port it and make it go native, but it doesn't exist right now, at least not in a supported sense. Okay. So all of these have recordings. This is a go. There we go. Got a YouTube recording. So where I can demonstrate using Vault secrets as, and I'm going to struggle with my bandwidth here, so let me know if I have issues. So I've got a Vault instance again, same thing running locally. Got local fuse mounted, and I can then cat all of these. I can write to them. I can view them with native editors, and everything is still audited via my standard audit device because it is by REST API. Okay. So whereas I maybe had to remember the command in Vault for listing my KV secrets and reading my KV tests, all I have to do is list them now and browse them, which is super helpful, right? And if I have 3 different languages, maybe a Python application or a Python deployment and some Terraform and some provisioner and a shell script that manages these secrets, I can do that then all using the same interface. All I have to do is use the language's mechanisms for reading and handling files. Okay.
Awesome. Thanks, John. Okay, so next question. Someone's wondering, how hard is it to perform the authentication process via REST? They're saying this is for the case where one wants to get a token as part of the script,
Okay.
as opposed to having one already provisioned.
That is the one question that MacGyver struggles with. No, I didn't demo that, not on purpose, just because there's so many options to authenticate. But here's the tricky bit about this flag now, this output curl URL. Sorry, ignore that. Operator log. Actually, you can still do a login. Yeah. So if I do a user pass example, so I specify a method user pass, my username equals test user. This is configured locally. This is not LDAP or external. The other examples, I had to actually specify this as the second, like arg0, arg1, arg2, curl. That doesn't seem right. I didn't do that right again. I suffer from major output curl. string. Thank you. Okay, thank you, John. Right. If I do this, it may or may not work. Right? So blah, 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 specify password. Okay. Careful with that. First of all, I'll put my password as plain text, which was actually invalid. So I can use that to generate an example and then substitute obviously a bash environment variable or a Python variable in a string. As long as I can trust that this is disposed of properly in whatever I'm using, that's fine. But there are scary other examples where vault, not a vault read, but a vault operator, something like that. If I'm going to do an unseal, and I put this at the second argument again, and a 0 indexed argument, I think this one will fail. Yeah, see this? It doesn't recognize that command being number 2. So the nice thing is they added this. The tricky bit is that the order sometimes matters. So one of the things I did here, cat vault, when I set this command, or sorry, this function, in fact, if I do this, bash, this is going to get really ugly and custom, so apologies for this demo in advance, but I set this function in my environment locally. Did I not copy that right? Yeah, okay. So I've now set a function in my environment. So if I do a which vault, instead of the binary or the location in my path, this is now a function. And as long as this passes on, it will shift. It will get rid of my which command, or sorry, it will get rid of my vault command, and then it will call the full path vault. And in my case, it's user local bin with the original argument that I put, which may be read or write, and it will inject the output curl string, right? So now in this case, if I do a vault read kv/test, normally that would output the actual result of that fetch, right? kv/test. In this case, because I replaced my vault command with a function that injects this output curl string, I get the resulting curl example. So I wish I could say that this works for everything. You will encounter things like the vault operator, and this will fail, right? Because it's supposed to be in a different order. Sorry, the text may be too big. But it generally, for vault CRUD operations, reading and writing secrets, managing secrets, that's an easy way to get going, right? If I just want to modify an existing deployment and say replace this with REST API calls, note that this is actually using my vault address. So it's not just a static example of localhost. This is actually substituting exactly the command you would use. And in this case, it says vault print token, right? So that doesn't just mean my environment variable. That means also if I've done a login and I've got a local vault token, boom, right? That supports any auth method I do. So if I've authenticated by an IAM role, my service account, right? Or my Kubernetes service account, this is universal. This will help in any situation. Vault print token is universal.
Thanks, John.
Okay. Does that make sense?
Yeah, I think so. Okay, so next question, and I think this is our last question. So if anyone does have a question that they've kind of been debating entering, go ahead and submit it for us so we can get to it. So someone's asking, just to confirm, I think on that earlier question, to summarize, are you recommending that we should bash script as the most lightweight option for containers to communicate to Vault?
I wouldn't recommend it as the preferred method. I recommend it as the stopgap method, right? So if this is what you have available, you can use it, right? And it's a simple way to get going. And if you're comfortable with that being your runtime in production, great. I mean, it is supported, right? The REST API is supported, full stop. So any way you can access it is supported. If you have a light version of libcurl or something that's smaller than the actual OpenSSL client or whatever else you need for that, then great, right? Because anything you use to access the REST API is still supported. As long as it's making an API call, that is something that our engineering team designed. The UX team is designed to list exactly what you can and can't do. As far as maybe a custom binding. In fact, if you look over here, sorry, again, I'm jumping around a little bit, and go to the API docs. There is a list of bindings. Where is it? And a lot of customers think, oh, these are all supported. That's a tricky part, right? Because if you have 10 languages that each have a different binding, you have a official libraries that we support. There's a Go client, there's a Ruby client that's supported. The rest are community, right? So Ansible, you would think, is pretty common. In fact, we have a lot of customers that use Terraform to provision, Ansible to configure, and Vault to secure. That's fine. It's just that this code is usually maintained by the Ansible crew at Red Hat, or maintained in conjunction with them. So we can't always guarantee a cross-compatible matrix of version. Right? In fact, the Medium post I was trying to look up lists an example where maybe the Ansible binding or the C# binding supports certain versions of Vault and certain versions that don't. So just test. I would say the number one rule is if you have a CI/CD pipeline, definitely test your integrations and make sure that builds with your version of binding work, or your version of curl or your script, whatever you're using, work in the end. Right? Bash is, like I said, a stopgap and a minimalist stopgap. The fact that you can do all that with a couple of lines of script is super simple, and especially useful for troubleshooting where you don't have other means. If that makes sense, right?
Great. Okay, thanks, John. So that was the last question. Thank you for your expertise on all of those and bearing with us through the evening. So as I mentioned at the beginning, this Hangout was recorded, and we will make the recording available on our website after processing. I will send an email out to everyone who registered with that recording link. Also, if you liked what you heard today and want to start exploring Vault, I encourage you to check out our Learn site. You can find it on our website at learn.hashicorp.com/vault. And then, John, if you want to send me the links that you referenced, I'll go ahead and
sure.
put those into the email to everyone as well.
Sure.
And so I hope everyone enjoyed today's Hangout and have a better understanding of Vault Secrets Management. Thanks for hanging out with us today, and a big thank you to John for his time. That wraps things up for us. Have a great day, everyone. Goodbye.
Thank you, everyone. Cheers.